going to do, we're not going to have too much of stats, Excel and other stuff. But today is a session where we're going to sum up a lot of things that we learned in our previous classes and talk about our role, which is a DA role. Now, how many of you understand what a DA is? Okay, data analyst, data analytics, okay, data analyst. Absolutely fantastic. So today we are going to talk about the role itself and how statistics can help you become a better data analyst. Okay, so I put together a few thoughts that I thought is important. So we're going to start with the understanding what statistics is all about. We'll also look at some basic statistics. I'll also share with you a lot of hardcore statistics as well, but we are only going to touch base on a few of these things. And then we will also look at few tools that are readily available for data analysts, to support their role. Okay, so these are the topics that we're going to discuss today. So I've got just five topics that we're going to touch in today's class, and we'll start with what statistics is. We'll look at what basic statistics are, what statistics is all about, and how statistics are going to help the data analysts, and how then you will put these statistics in use. So this session 4 is more of a dialogue that we're going to open up for all of you so that we can discuss. I need to understand if you have understood what this role has got for somebody who actually wants to be a data analyst. And then we're going to look at 5 tools. We call them as QC tools, which helps the data analyst to pinpoint 2 problems which they can then highlight to the very senior leadership for them to take some actions. All right. Now, what is statistics? I've got 2 things right here on our screen. One, pure dictionary meaning. So I looked at a Webster dictionary and I thought, let's see what dictionary talks about in terms of what statistics is. And that is what the dictionary says. It says numbers that have been collected in order to provide information about something. Okay. As an example, it says statistics indicates that 90% of the homes in this country have a television. So these are called statistics. Okay. Now 50% of people do not like ABCD things. Okay. Or out of the 135 crore people that are in India, these much percentage are men and these much percentage are women and these much percentage are children. These are all statistics. Okay, these are all numbers. Now, a hardcore definition for statistics, it says it is defined as a numerical data and is the field of math that deals with collection. That's very, very important. Step number 1 is collection. How do you collect your data, tabulate it, and then interpret the interpretation of that data. So a data analyst is somebody who has an eye of details on the data. If you give a data set to this data analyst, he is going to look at this data from a very different angle. So today we are also going to challenge how a normal person will look at a data and how a data analyst will look at the data. Okay, so that's to build a stage of what statistics is all about. So it's all about numbers. It's a hardcore field of math. It includes a lot of statistics built into it. Let's look at what basic statistics. In fact, let's do a deep dive into data. This is one, few slides that you're going to see, which I repeat in every session because these are the basics that each one of us should understand. Okay, every data analyst should understand what kind of a data is he dealing with. So looking at the data, you should be able to understand what data is all about. Now, in a broad term, data is divided into 2. Okay, one is called a qualitative data and the other is called a quantitative data, and both are data. Now, what is the difference between qualitative and quantitative data? Now, qualitative data is not numbers. Okay, these are certain comments or statements or inputs that we receive from people. As an example, if you are doing a survey, okay, and you are collecting certain numbers, and with those numbers, you also collect, at the end you have an input section which says, tell us more about your experience. So it is going to be English. Now, when it comes to English, it is very difficult to put those English words into numbers. So those kinds of data sets are called qualitative data. It was great fun attending this session. So if you comment like this, then those comments are called qualitative data. But if I say, can you rate this session on a scale of 1 to 5, and you come up with some number 1, 2, 3, 4, or 5, those are numbers. Those get qualified into the quantitative data. So as a data analyst, I need to understand what kind of a data I'm dealing with, either whether it is a qualitative data or whether it is a quantitative data, because then what we will do with the data will depend on what kind of a data are we talking about. Okay, so this slide talks about a little bit more on the qualitative data and quantitative data. So qualitative data, it says collection is very unstructured, because these could be certain text values or inputs from people or comments or suggestions or feedbacks. So those are qualitative in number, those are unstructured. On the other hand, the quantitative data is a collection of very structured data sets. Quantitative data is going to ask why kind of a questions. But quantitative data is going to talk about how much, how many, okay, in terms of numbers. Qualitative data is difficult to compute because since the nature of the data is such that it is difficult to put them into numbers and do some calculations on it. Qualitative data would go through some statistical calculation, because these are numbers. And the qualitative data is develops some initial understanding and define the problem. Okay, quantitative data normally helps you in recommendations and the final course of action. So these are some broad difference between the data itself, quantitative and qualitative data. Now, if you talk about the quantitative data, we have got further two segregations into the quantitative data. Quantitative data gets divided into two. One is called discrete, the other is called continuous. Now, anybody has got any idea about what these two segregations are? What are discrete data and what are continuous data? Any one of you? Anyone has got any idea? If you don't know, just say you don't know.
Continuous means like 0 to 10, 10 to 20, 20 to 30, like that, and discrete is like random number like 5, 10, 15, 20, and which are
Random
not
numbers. Sorry,
which are
Binod
not
saying something.
which are not arranged in proper form. Like if we see the continuous number, there is a CI like cumulative interval like 0 to 10, 10 to 20, 20 to 30, like that.
Okay. Fantastic. Thanks, Binod. Anybody else wants to add to what Binod said?
Sir, in continuous data, we take all the real values in a particular range, but in discrete, we take like integral values.
Okay. Anybody else? Because what I'm going to talk about today is very different, and from here onwards, you will never ever forget what the difference between continuous and discrete data is, because I'm going to talk about from a very different angle and perspective and very simple way to draw this difference. All right, now I will first talk about what continuous data is, and then we'll see what discrete is, and I'm going to give you a simple definition. Continuous data is a data that is collected, okay, that you can collect using a gauge or an instrument. Gauge or an instrument. Now, what what does this mean? What is a gauge or an instrument? If you have to find out how much is your weight, okay, to get this input, you need an instrument or a gauge called a weighing scale. So you stand on the weighing scale and the needle says, this is how much you weigh. I want to know the height, how tall I stand. I need a gauge or an instrument, right? I'm driving my car or my bike and I want to know how fast I am going. I need a gauge or an instrument. Okay. I want to know how much is the temperature around me. To know this data, I need a gauge or an instrument. I need to know what is the time right now. I need a gauge or an instrument, right? So anytime, any data that I collect using a gauge or an instrument will always be continuous. And any data that doesn't get collected through a gauge or an instrument is discrete. That's the prime difference between these two data sets, continuous data and discrete data. So anytime you have a data set, look at how has this data been collected. If you've used a gauge or an instrument, it is continuous. If there is no gauge or instrument that was used, is discrete. As simple as that. Okay. Now, gauge can give you any kind of a reading. Like temperatures can go into negative depending on what scale you're using. Okay, you're using a Fahrenheit scale, you're using a centigrade, centigrade scale, or any other scale that you're using. Depending on that scale, you can have any value in between that range. Somebody said it very correct. So it's a value between some scale or a range. Okay, so that's a broad difference. So when we move further into the data classification, okay, we started from here. We have qualitative data, quantitative data. Qualitative data, difficult to put in numbers and do some calculations, but we still can put them into some quantity, some quantitative data for ease of understanding. The quantitative data we said is divided into continuous and discrete. Now continuous we understood is measured on a scale, instrument, gauge. That is how it is collected. But discrete data has got further segregations. Okay? So there are 5 segregations that we're going to learn on the discrete side. In no order, one of the segregations is binary. Okay, so binary numbers, zeros or ones, right? So one possible outcome, that into 2 categories, but only one possible outcome. Yes, no, or black, white, under, over. So these kinds of data sets were just one possible outcome. So that's one of the categories called binary categories. Then we have something called an ordinal category. These two are ordinal category. It's some kind of an order. Under ordinal category, we have got 2 segregations, one called an unordered category, the other is called an ordered category. Now, what is an unordered category? If I am doing a data collection, I'm collecting some data on the top 5 food item that people like, or in a grocery store, I want to find out what are the top 10 items that sell the most on any given day. And so these 10 items or 5 items that I'm collecting has got no sequence. The 10, first could be anybody, second could be anybody, but no ranking. So I'm saying 10. These kinds of data sets are called unordered category data. But the moment you start putting numbers to this data, say for example, you collected 10 items, now you want to know which out of these 10 is the most selling item. Then the second one, the third one, the fourth one. So the moment you put a rank to these categories, then you shift from an unordered category to an ordered category. That is how we shift. And then one of the categories is called the count. Counting numbers are the most prevalent category within the discrete, because it's everywhere. So you want to know how many transactions flowed in, you want to know how many people turned up, you want to know how many people were absent, you want to know how many people are attending this session, you want to know how many people registered for the session. So it's counting numbers. So counting numbers starts from 0, which is all whole numbers. It could be 0% attending a session to any number attending a session. Okay, so that's the count. Then we have a percentage. Percentage is a little tricky because percentage itself is made up of two categories, a numerator and a denominator. And each of this category, numerator and denominator, is any of these four categories. It could be count, it could be unordered category, it could be binary, it could be anything. Okay, these are called derived numbers. These are not direct numbers, but percentages are basically derived numbers. Now percentage, don't get confused, we're actually talking about proportions. Okay, proportions, how many out of how many, and when you multiply that by 100 you get a percentage. That is how this category is defined. Can you give an example for discrete data as you gave about continuous? Yeah, Sejal, I'm going to talk about. Sorry, there is a question. Omkar says whole numbers like 1, 2, 3 are discrete, and 4.5, 5.6 height, weight, and continuous. Yes. Even within the discrete categories, we could have decimal numbers. Okay, and I'm just going to talk about that. We can have, because when you talk about proportions, okay, so the proportions are something which can be in decimal. Okay, so if you say 2 out of 3, this is a proportion. It will always be in decimal. Don't get confused. The definition or the difference is the gauge itself or the instrument. If the data is collected through gauge and instrument, it is continuous, else it is discrete. And now discrete could be any kind of number. Basically what happens, okay, and this is something, this is very interesting, that you should know. Whatever way or whatever is the discrete category on which you are collecting your data, whether it is binary, unordered category, ordered category, or count, we normally do not understand these data sets directly. Now if I say 200 people turned in today, the next question, very obvious question that people are going to ask is from how many people registered out of which 200 turned up, because 200 itself doesn't make any sense, right? So we need to know both. So any data type within the discrete is understood by us in this form, numerator and a denominator. Okay. So percentage or proportion actually becomes an exception within the discrete category. Okay. Because depending on numerator and denominator, you decide what the output is. So that is something that we need to understand. Now let's move a little bit more forward. This is importance of the data type. Why these data types are important for a data analyst to know. It is important because of two things. One, how are you going to treat this data in terms of what is the outcome that you can generate through this data set, and what are the different analyses that you can run in case there is a problem that has been cited, in any process. Say for example, there are people sitting and taking calls, or there are people sitting and doing some transactions, and we are supposed to take, let's say, 100 calls in a day, but I end up only taking 80 calls. Or if I'm supposed to do 100 transactions in a day, but I end up only doing 70 transactions in a day. And while you are reporting this as a data analyst, okay, you are also supposed to give some inside stories about what you are reporting. Okay. Now, when you get into the insight, then knowing your data will help you decide how do you give an output. Okay, what tools would be required to give an output, what graphical tools would be required to give an output, because we have different tools for continuous data and we have different tools for discrete data. So that is one very important thing for any data analyst to understand what kind of a data are you dealing with. The second important thing is to know that anything that you report in terms of metric, okay, metric. Now, metric is something which is defined, has got a target value against it around which you collect your data and say if your metric was met or not. Now, any metric for any operations can be set up either in a discrete way or in a continuous way. And let me give you an example. Okay, we have a metric called time to process. So people are sitting taking calls or doing transactions. I want to know how much time they have taken to process a transaction. Now, if I am collecting this data on what is the actual time that people took, which means that I'm using a watch or a clock or a timepiece to know how much time that I'm actually collecting a continuous measure. Okay, so actual time for each unit. But if I was supposed to complete a transaction in 10 minutes, okay, that's a target that I already know. If I'm supposed to complete a transaction in 10 minutes, then I'm collecting that how many of these transactions that I processed were completed in 10 minutes and how many of them actually took more than 10 minutes. So I am actually doing a discrete measure. Okay, how many within specification, which means I'm actually collecting numerator, denominator, quotients. Right? So I completed 100 transactions. Out of 100 transactions, 65 transactions were completed on time, which is within 10 minutes. I get a proportion. And flip side, the rest of these transactions, 35 out of the 100 were not completed on time. If I'm doing a measure like this, I'm actually collecting a discrete measure. Okay. Similarly, delivery time, how many number of times my order got late is a discrete measure. What is the actual time deviated from the target? So I was supposed to deliver in 30 minutes. Did I do it in 30 minutes? Or how much time? So whether I delivered it in 20 minutes, 25 minutes, 27 minutes, 31 minutes, 34 minutes. So actual time that I took is my continuous measure. Okay, and similarly the other things, customer satisfaction. If you only have a yes no questions, are you satisfied, yes or no, it's a discrete measure. But if you convert that into a scale of 1 to 100 or 1 to 50 and you start collecting data, that becomes a continuous measure. Okay, so any metric can either be defined as discrete or continuous. But what statistics says that if you can make your matrix more continuous, then it gives you better insight about what is happening in your process. Okay, because continuous data is more informative than discrete data. So something like this. Out of 200 deliveries that we made, okay, 7 deliveries were late. This is one information that you collect as discrete. Okay, 37 out of 100, out of 200 were late. Now the next obvious question, because you want to know or you want to do something about these 37 transactions that were late, you need to know what was the actual time that was deviated. If it was late, let's say I was supposed to do it in 10 minutes, did I do it in 11 minutes, 12 minutes, 13 minutes, 14 minutes, 20 minutes, or how much time did I took? Because once you know this information, then you can make some decisions and you can do more deep dive as to, if I was supposed to do it in 10 minutes, why did it took me 11 minutes or 12 minutes or 15 minutes? Okay, then only you will be able to answer those questions. So do any analysis, you would definitely need a continuous measure, okay, because it is going to give you more information. When it comes to discrete data, you require very large samples to make an inference. But for continuous data, even smaller samples can help you do an analysis and take a decision. Higher sample multiples are required for discrete data since the larger sample, so higher multiples discrete data. And discrete data does not allow you to understand what we call variation. In a while, we'll learn what this variation is all about. But discrete data can never, ever, ever help you understand variation unless you convert them into, certain continuous measures, or you assume them to be continuous and try to find process variation. So the bottom line, it says the more continuous we can make the data, the more it will tell us about our process. So as a data analyst, it is very, very important to understand what are the different matrices that I'm collecting data and reporting, and what is the structure of the data, whether it is continuous or discrete. If it is discrete, how are the discrete categories being captured? Are these binary numbers, yes, no kind of a data set, or are these in an ordered category, ordinal data in some sequence, or if they're only counting numbers, count data, or there are proportions that I'm collecting? Because this is the key for any data analyst to move forward. Data, because data is the backbone for a data analyst. I've got an activity here. I want each one of you to unmute or type in the chat box. I've got a list of certain matrices here. Okay, and let's see if you have understood discrete and continuous. Can we categorize these matrices in terms of whether they are discrete matrices or they are continuous matrices? Okay, revenue by a salesperson. Whether it is continuous or discrete. I'm sorry, somebody said something I couldn't gather. It is discrete. Okay. I didn't talk about this, but anytime you talk about money, this by default becomes continuous. Okay, don't ask me why at this point in time. Maybe if we have a follow-up session on more statistical things, we'll talk about why it is continuous. But by default, money becomes continuous. Okay. All right. Employee satisfaction survey score. Employee satisfaction survey score. If I'm collecting some feedbacks, fantastic, Shrikant. It is discrete. It is discrete. Fantastic. Cycle time for processing an invoice.
Continuous.
Continuous. Amazing. Average speed to answer for a call.
Continuous.
Amazing. There's only one voice. Continuous. Meters of cable required for installation.
Continuous.
It is continuous. Project completion on time. Project
Discrete.
completion on time. Project completion on time, whether it is continuous or discrete.
Discrete.
Or discrete. Anyone who wants to go with continuous? Yeah, Srikanth says continuous. Okay. This is the fun part. This could either be discrete or continuous. This could be both, depending on how I am collecting this data. If I'm collecting, so if I'm collecting in terms of the actual time, then it is continuous. But if I'm collecting whether the project was late or not, yes, no, it becomes discrete. Okay, fantastic. So you need to first look at how the data is being collected. Number of calls received by a call center.
Discrete.
Fantastic, Harish. This is discrete. Yeah, Khushbu, this is discrete. Okay, number of visits to resolve a service request.
Discrete.
Fantastic. This is discrete.
Discrete.
Amazing. Yeah. Lead time to fulfill a purchase requisition.
Continuous.
It is continuous because this is talking about time. Amazing. Percentage of parts stocked for service.
Discrete.
Discrete. Fantastic. Background check turnaround time.
Continuous.
Absolutely fantastic. It is continuous. Background failures.
Discrete.
Discrete. Fantastic. Harish says discrete. Yes, it is discrete. Attrition. You know what attrition is? How many people left your organization?
Discrete.
Discrete. Congratulations, you have understood the data types. Fantastic. I'm really amazed that it is, this portion is very clear with each one of you. Fantastic. Now let's move a little bit more forward. Now let's talk about some key statistical measurements that helps our data analysts to do a deep dive. So there are two key statistical measurements that you should always look at. One point of attention that I want each one of you to look at when we talk about, when we actually talk about these measurements, that these key statistical measurements hold good only for continuous data. Okay, so these holds good for continuous data. These have very less or minimal or no meaning for discrete data. This will not exist for discrete data. This will exist only for continuous data. So there are two measures. One is called central tendency. The other is called measure of variation. So let's quickly look at these three measures, and then we do more deep dive on why do we have these two, and why should we know both these, or we should calculate both these key statistical measurements. Okay. So measure of central tendency is mean median mode. I'm sure each one of you know about it. We learned from our school days. Mean is you have some numbers, you sum all those numbers and divide by the count. It gives you the mean. It is also known as your average. Average. Okay. Mean is more statistical term. Wherever you will see some statistical analogies or something written for statistics by statisticians, they will always refer to that as mean, not average. Then we have median. Median is you have a data set, you arrange this data set in increasing or decreasing order, and you take the middle value. That becomes your median. Now, if your data set is odd numbers, then the middle value. But if it is even number, then you need to take average of the middle two values. Okay, that gives you the median of your data set. And then we have the mode, which is the most frequently occurring value in your data set. That's called the mode. So these are three central tendency value that are possible for your data sets that you're collecting. On the other hand, we have measure of variation. How many of you understand what variation is? Before I get the depth of how do we measure it?
So how much our data is deviating from the mean?
How much data is deviating
From the mean.
from the mean? Absolutely fantastic. That's one of the definitions. Okay. But real sense, what variation is? Variation is any difference between two consecutive data points. Okay. And let me take you an example. Let's say you have a market which is, let's say, 200 meters from a house. Okay. First time you walk from your house to the marketplace, it took you 15 minutes and 10 seconds. Second day when you walked to the market, you only took 14 minutes and let's say 35 seconds. Now the distance hasn't changed. The distance is still constant. But what has changed is the time that you have taken. Now this data point to this data point is called variation. Now when you take a huge data set then the definition that you just said holds good. That how much I deviated from the mean value. And sometimes, or a lot of time, those mean values are already defined by us. That I'm supposed to take 10 minutes to complete a transaction. Let me see how much time I actually took. And then talk about variation. Now, is variation good or bad? If you have understood variation, then is variation good or bad?
Good.
Variation is good. Okay.
High variation is not good. Like
Okay. Now somebody adds, and I'm very glad somebody said high variation. Now, what is high? How much high is high?
like if the number is varying a lot from between two things, then it will show the negative. Like if we compare to the market share value, then we can say like the risk is higher than the low variable things.
Okay. You are supposed to you go and buy milk every day in the morning, and the dairy from where or the shop where you pick the milk is at a distance of let's say 300 meters. And approximately you take maybe 15 minutes. I don't know why I'm obsessed with these numbers, but they come automatically. Let's say you are supposed to take 15 minutes. Somebody said it, from your house to that shop is just 15 minutes walk. Okay. Now, you got up in the morning, you went and you came back in 5 minutes. Is this variation big, small, or what? Now tell me if this variation is small, big, or what?
We cannot identify like this. Like we have to do a date calculation on. Like if we have to compare, then we have to calculate like standard deviation. Then
Ah,
only we can say like it's a big or small or what.
okay.
Sir, if
Is
I
this a
always
good variation or not? Because
If
somebody
we
said
see
variation is
like this,
always good.
then no, I guess, because if on an average people are taking 15 minutes and you are taking only 5 minutes, then it's quite good, no?
The flip side. went, you came back in 35 minutes.
I think he was playing in the middle of the road, and that's why he took
Variation is neither good nor bad. Variation is variation, right? And I need to collect data to find out if this variation is good or bad. And there are statistical measurements that are available that can help you define if variation is good, bad, or ugly. Okay, but variation is variation, and I agree to some extent that variation is something that is inevitable to remove. Okay? So variation is going to happen. God has created this variation. When you look at your heart rate, and if the graph shows this, what does this mean?
Dead.
If your graph comes out like this, what it says, what it tells you,
no variation.
which means
He's taking 15 minutes.
a person is dead.
Since it is constant.
You know, your heart rate comes like this on an electrocardiogram, then the person is dead.
Neither he
Okay?
is inhaling nor exhaling.
So variation is good. You know, it should come like this. It could be like this. Ah, I'm alive. And that is so true, you know, with any process. If you make your process variation like, you know, a straight line, which you will never be able to do it. But if you force it, you are actually killing your process. Your process will look good like this. But to know whether your variation becomes bad, you need to measure it. And we have got three measurements. One is called range, second is variance, and third is standard deviation. Now, quickly, range is you take the maximum value from your data set, okay, the maximum value, and you take the minimum value and you subtract. Max minus min value will give you the range. Okay, so that's one of the measures. The other measure is called variance. Variance is basically an average square distance from the mean. Okay, average square distance from the mean. This is how this is written. Okay, so this is sigma of I minus mu whole square divided by n. That is how you find the variance. It is the average square distance of the data points from the mean. And the moment you square root this value, you get a standard deviation. Okay, so these are the measures. So when you measure central tendency and you measure variation, it gives you a lot of insights about what is happening in your process. And these both are two key statistical measurements. Now, what is variation in target? A simple explanation using a dartboard. So there are three dartboards here. You see one where you have the darts hit anywhere and everywhere on this board. This picture shows that the performance is not either on target. This is the target, and there is huge variation. That is what we call variation and not meeting the target. You look at the second dartboard. You see that the variation is not huge because most of the dartboards are very close, but they have not still hit the target. And the third is where we are on target and there is very less variation. Okay. Now the ideal state is centered on the customer target with very minimal variation. That is what we want to see with most of our processes. Okay. Now why do I need to measure variation? Now let me take an example and help you explain. Now these are 5 numbers that I've taken. Could be anything. Could be time for 5 transactions: 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes. I've just arranged them. Just got been random. Now, if I want to find out the central tendency, and let's say I want to find out the mean first, what it would be for these 5 numbers. What is the average for these 5 numbers?
3. Median will be 3, no? Central value.
Yeah, it is 3. Yeah, you learned in. Okay, so the mean is 3. Now, what is the median?
Middle value.
Median again is 3, right? There is no mode, so I don't know. Now let's look at another data set. Let's find out the central tendency for the second data set as well. What is the mean here? This data set 3, 3, 3, 3, 3. What is the mean?
15 divided by 3 is 3. Median is 3 and mode is 3.
It's 3, right? What is the median?
3.
What is the mode?
3.
It's also 3.
It's also 3. Amazing. Now I come and ask you, which process is good? This process is good or this process is good?
Second process.
How do you know?
Less
All
variation.
the central tendency are the same. 3 minutes, 3 minutes, 3 minutes, 3 minutes, 3 minutes. It's all 3 minutes. How do you say this process is good, second process is good? And the reason is you are looking at the variation now. You're now looking at the variation. Here the variation is 0. Practically not possible. Practically is possible. Okay, so this is 0 and we can find out the variation here. If you talk about range, the range is 5 minus 1, which is 4. There is a variation, and similarly I can find out the variance and the standard deviation as well for these 5 numbers. Okay, so hence it answers our question. Why measure variation alongside? Because most of the time I've seen whenever there is data that gets reported, we only report this. Only report central tendency on an average. This is our performance. These many number of calls were received. These many number of transactions were processed. These many number of people turned off. Only central tendency, because variation is an important statistical measure as it measures consistency and it complements the measure of central tendency to provide a complete picture of performance. As a data analyst, you should know how to calculate the central tendency, and you should also know how to calculate the variation, because variation is going to help you give a complete picture of your performance. Variation is an acid test beyond any central tendency measurement when you want to compare 2 or more group of data. It could be Monday versus Tuesday versus Wednesday. It could be the first day of the previous month, the first day of the current month, and the first day of the next month. Whenever you have to make comparison. Okay, so central tendency alongside with variation is going to be a better measure. Now, when it comes to customers don't feel the central tendency, but they feel the variation. You call a help desk, okay, and this guy sitting on the phone takes only 2 minutes and he gives you a resolution. You face a similar problem, you call again, maybe 2 days or 3 days or next month. This person again, picks up your call and now this person took 15 minutes to give you the same output, the same response on the same problem. That is what variation is. Okay, so customers will always feel variation. They will always say the last person took only 2 minutes and this person took 15 minutes. Wow, because that is what customers always feel. They don't feel the average. Now, the variation is something which is inevitable. You cannot eliminate variation, and you should not. But you should bring this variation to a point which is acceptable. Okay, and there are certain statistical limits that helps you decide this acceptability limit. And sometimes we talk to our clients and customers to see how much variation can they easily absorb. Okay, and then comes to the reasons. There are a lot of factors that are behind the variation. So typically variation in the inputs that you provide in the process and the methods or the process itself add to this variation. Okay, now when we talk about inputs, it could be machines, it could be people, okay, or it could be any other inputs, raw material that goes inside your process that can generate variation. So that is why we need to learn variation, or we need to calculate variation alongside central tendency. I'll take a few minutes pause to see if uh, you have any questions.
I have one thing like I am getting like what is mean median mode, what is central tendency, how it is being calculated, and meanwhile I got to know like what is variation. But like when we do a Excel or anything, I used to do that on a physical way, right? Learning the formula and I'm getting things like yeah, I'm getting the things, I'm learning the things. But in the case of here, like I'm not getting the confident, like yeah, I'm getting like I'm not able to catch the things like how the things is going to be used in a real scenario, or as you said, like to calculate the performance. Okay, but a
Yeah,
thing
yeah.
is not able to catch.
In a while we'll come to an example. Don't worry. In a while. So I have planned everything. I know it is difficult to comprehend because these concepts were we actually discussed these concepts in a lot of previous classes where we actually did a deep dive. We calculated how all these things are get calculated, and I think in a while, few slides down, uh, I have an example to help you understand where and how this is going to be used. Okay, just
Okay.
in few slides from now. Any other question, my friends? Any
These all are
questions?
used in problem solving also.
Absolutely, absolutely correct. Absolutely correct.
Okay.
These are actually problem solving techniques. And that's where the role of business analysts are changing and evolving and are getting involved over a period of time. I'll talk about the role also. I did some research on it, and I've been able to gather a few things which I'll share with all of you in a while. Okay, if there are no more questions, we will move forward. Yeah, so we spoke about two kinds of data sets, and there are basically two kinds of analysis. One is called statistical analysis, which is done on the quantitative data, the continuous and discrete. But we also have some analysis on the qualitative side, which is called non-statistical analysis. Okay, so that is the broader difference right now. So just to give you an example, there's something called a sentiment analysis that is done nowadays on the social media platforms. Now, these kinds of analyses are called non-statistical analysis. So it talks about, let's say I want to know uh, the happy meter today in my organization, happiness meter, right? So happiness meter. So I've got 3 smiley faces. One is frown. One is, just a straight line. I'm neither happy nor I'm sad, but there is one smiley. And people are asked to, and we do that in our organization every day. So when you log in, you have to say, what is your, this fun meter today. So
what
those
is
are
your mood for the day?
mood for the day.
Yeah, happy,
Absolutely.
sad.
Mood for the day. So those are non-statistical analysis. Which language is commonly used? In a couple of slides, I was actually about to talk about these new languages that are now getting very, very prevalent. And I'm so sorry we didn't add Python or SPSS. If you felt bad, sorry about it. We had just one option that we wanted to be correct or true. But R, R is used for a lot of statistical analysis.
Yes, more statistical concept, as Python is a general purpose programming language. So that's the one of the reason R is mentioned over here, and it is an open source software. That is also the main reason that we mention for the statistical purpose. As we say, R is a core statistical programming language. That is the reason, because Python is not only the statistical, it's a general purpose language. It used for several other purpose. I
Absolutely.
hope, Monu, now you get clarity. Okay.
Monu says he did feel bad.
Python is so popular. Huh?
Yeah, it is more popular. A lot of people don't learn R because of the reason it is only for statistics.
Yeah, and it is bit complex as well as compared to other programming
Python.
like Python. So that is one of the main reason.
The thing is that I've been using pandas and NumPy and all these things.
Yeah,
So
that's why your
pretty much,
love for Python is more. I can understand that thing. But yes, as I mentioned, Python is a general purpose programming language, and that is one of the reasons. But R is a core statistical programming language, a bit complicated than Python. Even the interface is not that much easy as compared to Python. Like you do the analysis in Python by using Jupyter Notebook, as you mentioned, you are using library, pandas, and other things. In R, you need to be a bit particular about all the libraries, the interfaces you are using. So that is one of the reasons. But both are highly useful.
So should I choose one or the other, or should I move on to R once I am comfortable with Python?
It's
You
your
learn as
totally call.
you want, you can learn. Just pick everything. Learn.
But
Learn
yes,
everything.
you are more comfortable in Python, you can grow in that also. There is no restriction that you have to learn R as well. But yes, at least you should have basic knowledge about that how the language actually works.
Absolutely. Because then only you will be able to also draw a difference yourself. Once you learn both R and Python, then you will be able to make the difference yourself. Because I learned R first, then I learned Python. So I found Python to be more easy language to understand, code, and put an output than R.
Yes, even the people who learn initially Java, C, C++, and then they learn Python, for them, it is very, very easy as compared to those programming language. So as you are already comfortable with the Python, once you learn R, you will differentiate how the similar kind of EDA which you are doing in Python, how it differ in R, what is the different functionality, like for the visualization in Python, you are using matplotlib and Seaborn. Here we have ggplot and some inbuilt libraries also. Different kind of scenarios, you will look and see the things differ in terms of machine learning also. A lot of different concepts included in R. You must explore. You will get to know better.
Yes. Yeah. Even the interface is difficult. I mean, to launch the interface for R is more complicated than Python. Yeah. Today we are not actually talking more in terms of the stats, but we're talking in terms of the role. And this slide will sum a lot of things here. And this is going to be an open discussion for us. I didn't know what to put here, but how statistics help, the data analyst. Now, whatever we've learned, if as a data analyst, you know all these things, then probably it becomes very easy for you to do a good job in a role. So I looked at profiles for a lot of organizations, and to sum up the requirements, I just put together all those requirements into this statement. It says if somebody is looking for a data analyst role in organization, what is it that they would look in a person as a definition? So it says anybody who wants to get hired as a data analyst is going to act as a gatekeeper for the organization's data. These were some key things. Data was a key thing here. So the stakeholders can understand data and use it to make strategic business decisions. So every data analyst is supposed to know what data is he working with. He is able to give an output of those data to the stakeholders so that they can understand and take strategic decisions. Okay. The stage is open for anybody to discuss it further. I can help add you a lot of things because I've been into a data analyst role myself for 8 years within my organization, and I also learned a lot of things while I was in that role. And I've seen, in the last 20 years with this organization, how this role has now shaped up and moved on, the data analyst role. And today, every operations, every operating leader needs at least couple of data analysts under him so that those data analysts can provide all the inputs that are required for him to take better decisions for the future.
Sir, I am working as a MIS executive, and I want to grow my career as a data analyst. Okay, and for that I am working on my skills. Like right now I am working on SQL. So like I know about the Excel, I know about the VBA, I know I'm learning about the SQL, and like I'm working on Python. Oh, sorry, Power BI also. Like what I have to do on next thing so that I would be like be a good data analyst, and no doubt like I am searching on YouTube also, like what is the main problem solving, like what is the problem solving for the data analyst, and like what the data analyst used to do for that solving, and like what the mean median mode used to use, and the standard deviation, and all the things I am searching. And when I was searching, I got to know like if the problem is there, then the solution used to be happen on the like in a case mode. Like if someone will say like who will purchase the iPhone, then when we'll purchase the iPhone, then obviously the higher class people will purchase the iPhone. And it was divided into three segments, like upper, lower, and middle. And upper was calculated in different way, lower was calculated in different way, and all of that. And I got to know like this is the problem and this is the solution. They are taking a dummy data. They are discussing about like how the data can be taken, and how we can take a steps to solve the thing. And all the things are going through only by the assumption, not by the data driven way, by the past data. So
You heard about this?
Six Sigma.
You heard about Six Sigma?
Yes, sir.
Absolutely. That is something that you should learn. This is going to help you get to those problem solving skills.
Okay.
Okay, so there are curriculums available. You can start with what we call yellow belt. This is a very basic curriculum. Then you can graduate to a green belt. And I think if you want to be in a data analyst role, getting graduated to a green belt is going to help you learn the other side. One side is strong for you because you said you are an MIS person, so I'm sure that your Excel skills, everything else is very strong. The moment you learn this, your other side also becomes strong, and then you can use both these skills to become a better data analyst. Alongside, I would also suggest you to pick up certain languages, like we were discussing about R, Python. So see if you can pick one of them. or you can say that you start by one and then you graduate to the other one. Those are definitely going to help you, because a lot of people today are looking for people who have a knack of data, who understand the data, and then they can also do some analysis and give those outputs to the senior leaderships. Okay, so stats is definitely a core competency for every data analyst today. They need people who understand statistics, and statistics is just focused only on very basic statistics. There are hardcore statistics available, but Six Sigma curriculums are designed to help you with those statistical statistical tools, how to use those tools, how to interpret data, and how to get to the core root of the problem, so that you can put them on the table for the senior leadership. Okay, so that could be one path. You want to learn, you want to know more about this, we can connect offline and I can guide you. Where do you get all these knowledge from?
Okay, sir, sure.
Okay, so as my friends just said, you are in a role of maybe a MIS kind of a person, where your role is more in terms only of collection and reporting. Okay, reporting is the key. 80% of your time goes in reporting, because data collection is something that is one time activity, or maybe you refine your data collection plan maybe every quarter, or maybe once in a year or once in a month. But reporting is something that is 80% of our time. That's it. It's an MIS. But as a data analyst, what do I get out of this report is something that is required. If you're only reporting, you're only an MIS person. But if you're giving insights, then you become a data analyst. That's the difference in the role. All right, I still have got a lot of stuff to cover. But as one of my friends said, where am I going to use this? So I've got some example here. Okay, so quickly, people, how do you put statistics in use? And that is a question that my friend also asked. How do you put it in use? I've got some some data set here, and we're going to use this data set to see how do you challenge this. Okay, so this is a data collected on number of transactions, right? For 19 days in the month of June. And you, as a data analyst, got these numbers. What do you do with this now? This is a real-time data that I've collected from one of my operations. What do you do?
Bharat, Monu has a question. Can you please stress on the importance of SQL and cloud computing in the context of data analytics or data science?
Okay, so SQL definitely is going to help you, because SQL is a RDBMS or something that is keeping your data. And the important thing that you should understand or learn on SQL is querying. How do you query your data? Because when you build a front end, so it's a back end that is only storing your data, nothing else. But if you know, you can structure your tables, you can align those tables in terms of when you query, how fast your query can become, or how you can use minimum tables to get maximum output and storage. That's where your SQL knowledge can help. Now, as a data analyst, you may not have an SQL knowledge. That is fine, but your statistical knowledge is definitely going to help you better become a better data analyst. Now, when it comes to cloud computing, now cloud is an enabler. Let's understand what cloud is all about. So let's say I've got an Excel. I'm doing things on Excel. Now, whether this Excel is kept on a standalone machine, or whether it is kept on a server, or whether it is kept on a cloud, the way I'm going to use Excel is not going to change. But what it will change is where it is kept. So cloud is today an enabler. Now, why people are going after cloud a lot? Because of the availability of your applications. Now, you created some data on your desktop. The best you can do is save it on a server. But would that server be available from any other location if you go? That is where cloud is helping. That you can use any of your data with any device at any location. That is how cloud is supporting your applications and the use of this application. That is what cloud computing is all about. Okay. Now there are more nitty-gritties available on how the cloud computing is done, how it enables. That's a different discussion or different topic. We can take at some other point in time. But that is what the basic difference is. Monu, does it answer your question?
Yes, sir. Thank you. So does it help me if I'm a fresher? I mean, do I have to know the knowledge about cloud
Monu,
computing?
if you are a fresher, then I would urge you to get into the cloud computing part. Okay, get into the cloud computing. That's the future. All right, let's come back here. So, there is no right or wrong way of doing analysis to this data. But definitely two things come as first. That what is the mean value or average or my central tendency, and how much is the variation. So let's say standard deviation, let's calculate standard deviation. And it is easy to calculate using Excel. This is stdv.s, which is for samples. Select and you get.
I want to know, like, when we are calculating the standard deviation or the mean, median, mode, anything, then we have to arrange the data in alphabetical order, right?
Alphabetical order. No.
Yeah, it's a compulsory or not? Like when I
No,
was
no, no,
seeing,
no.
no,
No,
no.
no, no.
Oh,
No, no. Alphabetical order is not required. But when you're calculating mode and you want to do it manually, then you need to range your numbers into any sequence. It could be either in a ascending order or in a descending order. It really doesn't matter. For median, manually. But if you're doing it through Excel, then you don't need to.
okay, sir.
Okay, it is going to still help you calculate that. Okay, now see something, something coming up here. Something very interesting coming up here. On an average, I'm doing 99 transactions. Okay, in 19 days, that is what my data is telling me. On an average, I'm doing 99 transactions every single day. If I find out what is the minimum transactions that I've done and what is the maximum transactions I've done, okay, so 3 is the minimum. And 219 is the maximum with a range of 216. This is huge. This process has got a problem. Okay. Now, if I was only looking at this mean, try and understand this, okay? And this will really help you set a context to your question that how practically we use it. Let's say if I was only looking at mean and a senior leadership comes and asks you as a business analyst, how many people do I require to run this process? Okay, so you only have this. You will say, I need people to manage 99 transactions because that's an average that is coming. Or even if you look at the median, it comes to 94. So you can pick any one of these and you can say, if on an average there are 5 minutes people are taking, and I've got 8 hours in a day, okay, so how much time per transaction is 1.6 minutes. If I have to do 99 transactions, then I need 99 times 1.6. I need 158 people to do this process. Okay, just rough estimate, 158 people or 159 people to do this process. So you deploy. Now what happens on a day when you get only 3 transactions? 3 transactions. People are playing cricket on the floor because there is no work today. Only 3, anybody can pick 3 and just go on. Similarly for 4, I mean closer to this. Imagine what would have happened on a day when you got 919 transactions, where your capacity is only to take 99 transactions. What would have happened? Everything, every other transaction over and above 99 would have been a backlog for the next day, to the next day, to the next day, because next day we got 87. Imagine backlog adding 87, 120 got added to 87. What would have happened? You know, you could have only completed 99 in the backlog for the next day. Imagine those customers who are waiting to get their transactions. Okay, 108 got added here. Similarly, then backlog, and this backlog would never finish because you are planning only for 99 transactions. Okay, this is what comes out when you start calculating variation. Okay, this variation is huge for the process. So you need to find out how do you manage or tackle, or is there a way to get a better forecast? Okay, that is one of the solutions for these kinds of huge or highly varied processes. There could be other things also. Now, I could also look at, it is a mix of these transactions. Okay, I could also look at the day when these transactions have come and see the pattern. See, Thursday I got 3, next Thursday I got 219. So huge difference. Even on Thursdays to Thursdays, I can compare Mondays to Mondays. I can compare, you know, each day to see if on which day there is not much transaction. Now, if you look at this next Thursday, again there is a chance of high. Next Thursday again it drops down. Okay. Similarly, I can do comparison with other days of the week to find out if I can find any pattern. If it's random, I would definitely need better forecasting for this kind of process. I could dissect the type of calls that are coming in and then queue up. Let's say I can make Q1, Q2, and see how many transactions are falling in each of these queue. And let's say if my focus says that on certain days I will get very less transactions in Q2, I can train few people from Q1 to Q2 calls or transactions, so that if there is a difference in these two queues, on an average I'm still able to keep my numbers. So only as a business analyst, when you know how to analyze this statistically, then only you will be able to give these outcomes. And this is one of the practical scenarios that I thought I will share. And this is the real data collected from one of my operations. Real data, and we have a problem here in this process where we are not able to match how many people do I require. Okay, and you know, we have deployed a black belt to look at this. I am a master black belt myself, so I've deployed a black belt to look at a lot of things, get more data, see the patterns, and come back with certain solutions. Sir, does that really help?
Could you please explain that Q1 and Q2?
Q. This is not quarter 1 and quarter 2. This is Q. Type of calls. That is what another analysis that I've asked him to do, to identify the type of calls. Okay, what kind of queries people are asking, whether it is just a simple query, okay, or they have a complaint, or they have a suggestion, I'm just giving example here. Okay, this can also help. Okay, so I can queue this up. I can segregate. I can have an IVR saying, do you have a complaint? Press this. Do you have a suggestion? Press this. Do you want to talk to this? Press this, and I can queue those things separately, so that I can manage them more effectively. That is what the queue. This is not the quarter one, quarter two. This is the type of calls queue. Am I making sense, my friend?
Yes, sir. One more thing, like here we have to calculate the mean, right, and the average, and from that we got to know like per day on an average 99 transaction is what we can hold. And then after knowing the things, like we calculate the range, and the range was giving like 216, and we got to know like it's a huge difference, so it's not a proper calculation. So for that we have done like that q1 and q2 to solve the things, right?
Okay, so this is not anything to do with the correctness of the data. This is what data is. That is what data is revealing us. Okay, so these are, queuing is comes sheer out of my experience. Okay, dealing with um, over 20,000 projects today. So this is coming sheer out of experience, that when we queue these things up, when we segregate, these transactions to see if there are different. Now, could be a reason that is only one type of a call that is coming in. I don't know. Still not collected the data. So these are only, way forward. How do you want to move forward? How do you want to tackle this? Because I definitely need a better forecast to be able to manage my people. I can't put 158 people for the sake of putting, because I still see a lot of variation. Can I another idea could be, can I have different number of people on a Monday, different number of people on a Tuesday, and so on and so forth? Or there could be that, can I have a temporary staff or a daily wages staff as per my requirement? So Monday I need 10 people, so I just call 10 people. Tuesday I need 20 people, I call 20 people. But even before I do any of those things, I definitely need a better forecast. And that is what we're trying to do. We're trying to figure out how can I do a better forecasting of number of transactions, so that I am able to make a decision on how many people would I need on a daily basis, because it is difficult to get a dynamic roster. Very difficult. I can't all of a sudden say 20 people don't come tomorrow, and ask 10 people to come tomorrow and all of it. These are, I would say, these are not actually statistical tools, but these are part of what we call QC tools. I put statistical, and then I thought that when we will do the sessions, I am going to clarify this, that you understand. These are QC tools, not statistical tools. Okay, but some of these tools do help you with identifying the problems. So all these tools help you identify the problem. These are hardcore statistical tools, okay, that we use for our analysis. Okay, ANOVA is one of them. Okay, then one sample t-test, two sample t-tests, Wilcoxon rank test, Mann-Whitney test, Kruskal-Wallis test, one variance test, two variance test, F-test or Levine's, Bartlett's Levine test, one proportion, two proportion, chi-square, logistic regression, correlation and regression. These are hardcore statistical tools that we can have knowledge on. We can have other sessions to learn, what these tools are all about, how do we use it. This is hardcore part of your, Six Sigma statistics portion. So in the interest of time, let me quickly run through these, 5 tools that if a data analyst know about these tools, then it is definitely going to help them. One of the tools that I suggest that every data analyst should learn is a control chart. Quickly, what is a control chart? A control chart is nothing but it is a time series plot. It is a time series plot which is always plotted on an increasing time scale. It has always to be an increasing time scale from historical time to the current time. And these are the data points that get plotted. So these black dots that you see are the actual data points. This black line that you see is called the center line. Now the center line could be mean, median, mode, whatever you pick as your central tendency. So this is central tendency. Then these are two statistical limits that help you understand there is the variation that is there in your process is good, bad, or ugly. And there are rules to know. One of the thumb rule that we look at is that none of these data points should go outside these statistical limits. Okay? If any data point goes outside the statistical limit, then it's a bad variation, this side or this side. This is a bad variation. Now, what do we do with these bad variations? We investigate. Okay, so we investigate to find out why did this happen. Okay, because once we know the why, then only we will be able to put a solution. So a graphical tool for monitoring changes that occur within a process by distinguishing variation that is inherent, because variation is going to happen, it is bound to happen, you can't do anything, from the variation that yields changes to a process, which is called special cause. So any time any data point goes outside the control limit, it will be a special cause. We need to know about this cause. That is what control chart is. You can draw a control chart every 5 minutes if you are in a dynamic process where you get a lot of transactions. You can do it at 30-minute interval. You can plot it at a 1-hour interval, or you can plot it at an interval that is more convenient for your kind of operations and processes, the way your inputs are coming and the way your outputs are going. This can be used real time to learn what your processes are like, and in case there is something that goes amiss in a process, can be caught real time. Okay, more to come on and further sessions on these tools as well. How do we draw it? How do we do it on Excel? How do we interpret all of this? We will talk.
How that line has been calculated, like that dotted line, so that
Okay.
if it cross
I
that
know a
dotted
lot of questions are going to come. So what we do with the data set that we have, we calculate the standard deviation. We multiply standard deviation by 3. We add to the center line, we get the upper control limit, and we subtract from the center line, we get the lower control limit. 3 times the standard deviation. So this is your control limit. So this is calculated from the data itself. You have a
every
data
time
set.
every time we have to calculate by 3, right?
Um, yes. So I'll use this as an example. Okay. Okay, so this is the mean. Then what we do, we calculate the standard deviation. Okay, and then I multiply the standard deviation by 3. So UCL stands for upper control limit and LCL stands for lower control limit. What I do, I add the standard deviation times 3. I get the upper control limit. I subtract I get the lower control limit. And then I just draw a line chart. I get a control chart. Okay. Now let's say if I add another data set, see what is going to happen. Let's say there is another data set I get. Now this is not going to remain the same. This will dynamically change. How would it change? I have another data point. So what I'm doing right now, I'm just taking some future data points here, okay? See, the standard deviation will change. Let me take some future data points. So the standard deviation will change, 3 times standard deviations will change, mean is going to change, UCL and LCL will change. So this chart is automatically going to change. Let me add few future data points to make it dynamic. Okay, so just see what happens. Okay. See what happens. See, that is how we make it dynamic, because these are calculated from the data itself. And the good part is, though this process is with huge variation, but control chart, okay, none of the data point is going outside my control limits. Even with this huge variation, it says that, okay, still this process is okay. Okay, so that is how we use control chart. Now, when it comes to control chart, there is not one single control chart that is available. We have 7 different control charts depending on, you know, how I am collecting my data and what is the data type. We do have control charts for discrete data. So there are 4 control charts for discrete data, and there are 3 control charts for continuous data. So maybe in a follow-up sessions, we can do more in-depth thing on control chart, because this is one tool that I want every data analyst to understand to the T, because this is one tool that can help data analysts to do a real-time reporting on what is happening in your process. Real-time reporting. Every 30 minutes, 10 minutes, 1 hour, whatever is that, you collect one data point, you plot it, and zoop, you get something immediately, real time. We display these control charts on a big LED screens on our floors, where data analysts are looking at these data sets, different matrices, and they are just, you know, plotting these control charts at every regular interval. Today we have also deployed bots to do all these things, collect data, do all these, you know, analysis, and generate outputs. So my bots are doing this for me today. Okay, friends, I think let's pause for today. There are more tools here which you guys can just run through once you get this presentation. But I assure you, we are definitely going to have some follow-up sessions only on these tools. How do we do it? And there are many more tools. These are not only the tools, there are many more tools. One session we can keep on these tools, one we can keep on you know, hardcore statistical tools, how to use, how to interpret. But you know, if we need bigger sessions, maybe a very structured one, we can think of doing longer sessions on more problem solving things. Okay? Yeah. I've got 16-hour sessions on problem solving using Lean and Six Sigma both, because this is one topic that I believe that if data analysts are exposed to, they definitely become a better data analyst. So I started with MIS, then I learned these skills. I became a master black belt. So today I've got these 2 skills. Now I also know technology. I know R, I know Python. And very recently I'm getting into the cloud computing part. So I've done my level 1 certifications on the cloud. So, you know, everything is now adding up.